One last thing that we can touch on in this unit is a more real-life use of some of these chemicals and formulas that we've been investigating. For example, who can tell me the name of this guy? What's he called? What was that? That was really fast. I'm impressed. Yes, lithium perchlorate. All right. Now, lithium perchlorate it's referred to as a salt, but all ionic compounds are referred to as salts. But the way that this is more commonly stored actually alters its formula. Something that we could do to lithium perchlorate, let's say that it's in crystal form. Let's say that this pile is a pile of lithium perchlorate. There it is. It's crystals in my hand. What we could do is add those crystals to a beaker of water. Now, if we did that, if we added them to the beaker of water, we would refer to this water as hydrate. So when I say hydrate, it's a new vocab word for you. It's simply referring to another chemical way to say water. But let me ask you this. If after we added the lithium perchlorate to the water, if it were to absorb water, if the crystals were to absorb water and we dried it out, what would you expect to be true about this pile of the substance compared to this one? It would weigh more. This bottom pile of salt has absorbed water. There was more stuff in it now than there was prior. So the masses would be different. This was lithium perchlorate, and this was lithium perchlorate with hydrate absorbed, which would make the masses different. When this happens, the formula has to represent the fact that this compound has absorbed some water. And here's the way it's going to look. There's going to be a dot, like a multiplication dot from algebra is kind of what it represents. And it's going to tell you that there is hydrate in it. But sometimes there's not just 1 mole of hydrate, and that's real important. Here's a number that's good to just know. You don't have to memorize it, but it's good to know that water has a molar mass of 18.015. All right, where does that number come from? It's 2 H's and an O. You can go add it up. 2 H's plus 1 O is that number. But we're going to use that number a lot. It's a good number to just know. This lithium perchlorate might not be made with just 1 hydrate, though. It could be made with 6 hydrates, for example. I made that number up. But tell me this, sorry for the 5th grade math here, write down the mass of 6 hydrates. There's the mass of 1 hydrate. Write down the mass of 6 of them. What'd you get? 108 point what? 09? Okay. So, no brain surgery there, but my point is that lithium chlorate is maybe made with 1 mole of water, or maybe it's made with 6. Don't write that. But the difference would be the mass that the water brings to the equation. All right? 1 mole's that much, so 6 of them is that much. Simple math, but it puts us in a situation where I can ask you some hydrate questions. Let's say that we had a substance that was lithium perchlorate hydrate, but we don't know how many moles of hydrate there are. Now, we're gonna draw out a little story here. I want you to draw it out too, but follow along. I want it to make logical sense. Let's say that I dump out some crystals of just lithium perchlorate, not with the hydrate, just lithium perchlorate. And there's a scale. Whoa, there's a scale. and I dump some crystals onto that scale until it reads 4.78 grams. 4.78 grams. That's how much LiClO4 I've got. But then I take those crystals and I dump them into water. Right there. I put the crystals into the water. I remove them from the water and dry them out. And when I do, are they going to have a lighter mass or a heavier mass after sitting in that water? Yeah, they're going to absorb some water. And after they do, the new mass is 7.21 grams total of my sample. Let's analyze what happened here. We know this number. This number is the amount of that we have. That was 4.78 grams of lithium perchlorate. All right? How many grams of water are in my sample right now? Not zero. We right now at this point. Sorry, I didn't mean to. So at this point, after we hydrated, 2.43. Now, if you are sitting there wondering where 2.43 came from, here's what we know. When we started, we had just lithium perchlorate, but then we dumped it in water. And when we were done with that, it got heavier. We didn't have water before, and now we've got water. So the difference between these two numbers is the amount of water absorbed, right? Using these values, we can come up with the moles of water in the formula, using steps that you already know. The good thing about teaching this right now is because it's totally married to the concept that you already do for empirical formulas. Step 1 and 2 over there, solve the problem completely. We know that step 1 says, divide that number by the molar mass of the compound. So we are going to have to add up lithium perchlorate, which is kind of a headache, but we can do it. Water's is 2.43. Hey, what's water's molar mass? You know that? 18.015. Very good. You might have looked, but water is 18.015. Now, we need this value for lithium perchlorate, which is going to be a molar mass again. So, we need 1 lithium, 1 chlorine, and 4 oxygens. All right, lithium has a mass of 6.941, chlorine 35.453, oxygen 15.999. So you'll notice we've been doing a lot of molar mass today, so make sure that you're good at adding this up. Look on your periodic table. You don't need me to tell you that. Does anybody have this molar mass of lithium perchlorate?
106.39.
So again, guys, 106.39 is 1 lithium plus 1 chlorine plus 4 oxygens. Now again, this is just like empirical formulas. That was step 1. We're getting a mole count. So let's get these values together. 4.78 divided by 106.39. I get 0.045. On the bottom, 2.43 divided by 18.015, I get 0.135. Now, just like empirical formula, All we did was we divided the number that we had by the PT. What do we always do second with those numbers? Divide by the smallest one. So be careful not to get mixed up. The smallest number I see here is the 0.045, which is going to reinforce that we only have 1 mole of lithium perchlorate. But we're trying to find out the moles of water. So divide by the same number. How many moles of water did we have? 3. And that's this big number. We call these coefficients, by the way. I don't know if I said it earlier. The big numbers are coefficients. They'll be a big part of this class next unit. But this is lithium perchlorate trihydrate is one way to say it, but 3 hydrates. Let's do one more, and then we'll be done for the unit. Tomorrow, we're going to do a lab that totally represents the problem I'm about to show you. We're going to use a different compound, but we're going to play with some fire tomorrow. But again, I want you to follow along my little story. Let's say you're writing that I've got barium chloride, and we know that it is already a hydrate. What we don't know are how many moles of hydrate we have. We don't know that coefficient. Now, I've got this crystal in my hand, barium chloride, all right? And it's already hydrated. It's already got water absorbed in it. I can't see it. It's a dry crystal, but it's got water in it. What could I do in the lab to try to get the water to leave the crystal? Burn it. All right, I gave you the hint with fire, right? If we light it on fire, we can get the water to boil off. So let's add fire. Let's say that we had 5 grams of this. 5 grams of this hydrated salt. And we're going to add heat. And it starts boiling, and it starts giving off steam. We can even see little water droplets forming. And after it's all said and done, after it's still being heated, but it's not giving off any more steam or any more liquid, it's got a new mass of 4.26 grams. So that was after we heated it, stuff left, so of course the mass went down because we removed stuff. We've still got the crystals. We've got the crystals sitting here. And that's what we have. We've got 4.26 grams of barium chloride. And again, here's the question. It's a little bit of subtraction. How many grams of water did the original sample contain? How much? 0.74. Again, they get that number from the difference between these. It was 5 grams when it was both of these. It was 4.26 grams when it was just this. So the difference is the water, which was 0.74. And now finding that missing mole number is real easy. Let's go through our process. We're going to divide the number that we have, 4.26, by the periodic table masses. Here, water's is 0.74. We already know water's mass, though, because we're brilliant for AP, kids. 18.05. We do need barium chloride's mass, so I'm going to let you find that. You need 1 barium and 2 chlorines. See how far you can get on this last problem to figure out that mole number of hydrate. If you're watching the video, pause, figure it out, and unpause. When I add up BaCl2, I get a molar mass of 208.234. So now I need my mole count. 4.26, quiet please, divided by 208.234. I get 0.0205. When I divide the bottom, 0.74 divided by 18.015, I get 0.0411. The final step is to divide those by the smallest of those. What's my smaller number? All right, so that's going to give us 1 mole of the salt, barium chloride. How many moles of hydrate do we have?